So this is the picture that we graphed in the previous video, and so I want to show you a little bit more information about some special polar graphs. So several important types of graphs have equations that are similar in polar form than in rectangular form. So for example, the circle with the polar equation r equals 4 sine theta has a more complicated rectangular equation, x squared plus y minus 2 squared equals 4, right? So that's the rectangular versus our polar equation. Several types of graphs that have simpler polar equations are shown below. So this is our limaçon that we graphed a little bit earlier. And so there's a little bit more information, like you can take the a plus b, a plus or minus b of cosine and sine. A and b have to be greater than 0. And so notice, looking at the ratios, if the ratio a over b is less than 1, then we're going to have a limaçon with an inner loop. Then you get a cardioid or a heart shape when the ratio is 1. It's a dimpled limaçon if the ratio is between 1 and 2, and then it's a convex, so no dimple, if a over b is greater than or equal to 2. So kind of neat what kind of graphs come out of these. Then we graphed our rose curve. So earlier we graphed a rose curve with 3 petals here. And so looking at this example here, it's 2 sine of 3 theta right there. And then the other one, I don't have the picture of it, but looking at the equation, it's also 3 theta. So notice with the rose curve, it's n petals when n is odd. So if it's 3n or 3 theta, then it's going to be 3 petals. Now when it's even, so for example here, 2n petals when n is even. So if n is 4, then we have 8 petals. If n is 2, then we're going to have 4 petals. So the other type of special polar graphs are circles and lemniscate. And so we have the circles here. If you have r equals a cosine of theta, notice that it is still symmetric across the polar axis. And then this one is symmetric across the pi over 2. Notice a is our diameter, so whatever the number is in front. Then our lemniscate, it's that figure 8 shape, almost like an infinity shape here. So that's really, really cool. And so notice that if it's sine of 2 theta, then it's going to be symmetric across the pole. And then if it's cosine, it's going to be symmetric across the polar axis. And so we're going to get some practice in graphing these next. So let's sketch a rose curve. So sketch the graph of r equals 3 cosine of 2 theta. So first of all, the type of curve is a rose curve. Then we know that because it's a rose curve and it's even, we're looking at 2 times n, which is 4. So we're looking at a rose curve with 4 petals. The symmetry is going to happen in a couple places here. So 4 petals, it's cosine. It's going to be symmetric, or symmetry, with the polar axis, pi over 2, and at the pole. Okay, and that's, again, looking at that it's cosine, looking at that it's even. Our max value of r, so when is that going to happen here? That's when cosine of 2 theta is going to equal 1. And so when it equals 1, we know that max value is going to be a 3. So when does 2 theta equal 1? And that's going to be at 0, pi, 2 pi, and 3 pi. I do a couple because then when you divide by 2, it changes it, gives us a little bit more points or more values. So we know that the max value is going to occur when, divide by 2, when theta is 0, pi over 2, pi, and 3 pi over 2. Now let's look at the 0 of r. So that's when 0 equals 3 cosine of 2 theta. So 2 theta, when does that equal 0? That equals 0 at pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. Then divide by 2. So we know that our zeros are going to occur at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, you could possibly plot these points, but I think it gets a little difficult sometimes because you need to know the flow of the curve and what picture it's making. And so it really is very helpful if you just kind of go in order. So let's start at 0. So we're looking at 3 cosine of 2 theta. So 3 cosine of 2 times 0, which is just 0, that's going to be 3. So I know it's going to be 1, 2, 3 here. And then I know that it's going to be, because we know it's already reflected, it's symmetric here on the polar axis. I know it's going to also go on this side. It's also symmetric across the pi over 2, so it's going to go on the other side. Now let's try pi over 6. So 3 cosine of 2 times pi over 6. So we're really looking at 3 cosine of pi over 3. And so cosine of pi over 3, that is a half. So this is 3 halves. So at pi over 6, we're at 1.5 right here. And then it's going to be the same on the other side. So I know it's starting to make this curve here. Now let's look at pi over 4. Now the reason why I'm picking that is because I know I have a 0 there. So pi over 4. 3 cosine of 2 times pi over 6. Pi over 4, sorry. And so we're looking at 3 cosine of pi over 2, which is 0. And so that's what I wanted, right, to give me a better picture of what's happening here. Then let's choose pi over 3. So 2 cosine of 2 times pi over 3. We're looking at 3 cosine of 2 pi over 3. At 2 pi over 3, cosine is negative. So this is 3 times negative a half. So that's negative 3 halves. So at pi over 3, we're at negative 1.5. So we're actually down here in this quadrant here. Then let's choose the next value. Let's choose pi over 2. So 3 cosine of 2 times pi over 2. We're looking at 3 cosine of pi. So this is at negative 3. So at pi over 2, we're at negative 3. So just recognizing what's happening with the value. So when it's negative, it's going to go on the other side. Down here. Oops, I have an extra dot there. Down here. 1, 2, 3. And then I know it's going to go this way. Oops, right here. So here is, start to make this curve here. And so let's go ahead and choose another value. So after pi over 2, let's choose 3 pi over 4. And at 3 pi over 4, that's going to hit our 0. 3 pi over 4, if you plug it in, 3 cosine of 2 times 3 pi over 4. Notice we're looking at 3 cosine of 3 pi over 2, which is 0. So it goes back to the pole, not the origin, but the pole. Right there. Then let's do another value. Let's choose 5 pi over 6. So this is 3 cosine of 2 times 5 pi over 6. So 3 cosine of 5 pi over 3. And at 5 pi over 3, that is a positive cosine. So that is positive 1/2. So we're looking at 3 over 2, or 1.5. So at 5 pi over 6, we're at 1.5 right here. Then it's going to reflect on the other side. So, and then we know that's a maximum value already, so we can use that. Then we also know we're going to hit the 0 at 5 pi over 4. We already know that's 0. Then let's try the next value at 3 pi over 2. I should be up at the top. So if I plug in 3 pi over 2, 3 cosine of 3 pi over 2, 2 times 3 pi over 2. Then we're looking at 3 cosine of 3 pi, and that's going to be 3 times negative 1, so at negative 3. So at 3 pi over 2, we're at negative 3. So if this is 3 pi over 2, we're on the other side here, and so negative 3 is up at the top. Now, because we already know what the rest of the picture looks like, we can go ahead and use symmetry to finish it up. So we got lots of points here, so we know that it's going to continue, finish the rose petal here, and it's going to finish here. And so here is the graph. Go ahead and try this example here. Sketch the graph of r equals 3 times cosine of 3 theta. So I hope you got this picture here. I'll leave it here on this picture, and then that can help you out.